it have a name? Do you know what it is?
Unfortunately, I don't know the name.
What was the name of the first one?
Stream is the name of the company, and that's founded by Dominic Williams and Tom Dean. Okay, so I don't know, is there anybody here who is, just to help us get a bit acquainted, is anybody here who is new not only to Ethereum, but to the cryptocurrency space? All right. Alex, I don't think you qualify actually. Okay, would you tell us? I guess we talked briefly, but you get your mouth full. Anybody else who's willing to tell us their interest in Ethereum?
Okay, I can do it. So, guys, I'm just trying to reveal the current client for Unity 3D with the VR capability. So, say your keys, but everything is floating in front of you in a VR headset. So, if anyone is interested in collaborating this, come talk to me.
Okay, very good. All right, so anybody else want to have any newbie? Let's say right up here in the front row, easy to accept. You're new to Ethereum.
Never tried to write anything for code.
Okay, very good.
Definitely new, and I work for a big French telecom, and we're right now kind of at the stage of for our R&D, figuring out what kind of blockchain platforms, one or more, we want to try to develop applications on.
What would a Qualcomm company look like? Any application?
Okay, pay each other with your. I'm just not saying you are. I'm just saying that that's very good investigate. That's a simple type application. There are more ones, but telecoms these days kind of sort of a lot of computing and other services that are not just giving you access to your mobile. Very good.
Okay, so I'll just throw out a few names. So if you want, it's always important to know who to talk to, right? If you want afterwards, Martin is going to be mobbed with people wanting to talk with him, I guess. Of course. So of course, Martin, one good guy to talk with. Natalie and Patrick, where's Patrick? Oh, he's back behind there. They're working on an Ethereum-based hedge contract. You guys are still working using Ethereum, is that right?
Oh, absolutely, yeah. We're about to launch some really interesting things.
Okay, I guess we'll 2 sentences. Great.
Well, we're going to launch some hedge contracts on Ethereum. Great. Very good.
Excellent. And Daniel Caraway has the mysterious finance starts as well. Let's see, who do I write down? Yes, please. Augur is hiring. Okay. All right. And are you with Augur?
Yes, my name is Gary.
All right. Very good. Okay, so let's see. Peter is interested in identity on the blockchain. At least you chat with him about it. You guys, it seems like you guys always have some projects. Some guys are working on these days.
Hi guys, my name is Libra from a company called Koppelman. So we're doing KYC on blockchain, and I'm going to help you for our project.
Okay, KYC as in know your customer.
Yeah.
Okay, enough of that. So Martin he has this unique background that he implemented a prediction market on Bitcoin, Fairlay, and one on Ethereum, Gnosis. So if he doesn't mention that, you should ask him about the comparison between development platforms. So Martin, please.
Yeah, thank you very much. All right, so welcome. Glad you all came and that there's so much interest. After all the hiring announcements, I could add can add one more. So I'm working with Consensus, and they are also looking into hiring all kind of developers. So talk to me if you are interested. Okay, so this is the first meetup of the new meetup group, San Francisco Ethereum developers. My midterm or long-term goal with this meetup group is that it will be a place for exchange of experience or active Ethereum developers. I used to live in New York, and there was a really cool DApps meetup group every other week, and we discussed just latest Bitcoin improvement proposals and all this stuff. So that is my midterm goal for this meetup group. Short term, I think there's lots of need for some basic education. So I will start this meetup group with most likely 3 consecutive meetups that should give you a basic overview of how to build, how to get started, how to create something on top of Ethereum. So let's create some dApps together. Shortly, my background, as Chris mentioned, I went into the crypto space full-time, I think, 3.5 years ago, and built this company called Fairlay, Bitcoin prediction market, still running, but now I think Ethereum is more interesting because with Ethereum with Bitcoin we also had the goal to build a decentralized prediction market, and maybe it's possible. With Bitcoin I think it is possible, but it's just way more complicated than with Ethereum. So what we ended up doing is just using Bitcoin for payments, but the logic was just a traditional database thing and a centralized service. Now with Ethereum, it is easy to implement also the logic of the prediction market on the blockchain. Okay, so my idea for this series of meetups will be that I introduce 3 small ideas for simple dApps. Then I will go into show you what are the first steps if you want to build them. So I will show some developer tools. I will show you how Solidity contracts look like and so on. And then if you want, you can try to build one of those or all 3 in the next week. I mean, in the end, you only learn it if you do it. And I will code them then myself, those 3 dApps. And so next time, or I can then show, okay, how is it possible, what are the possible solutions, or what is one possible solution, and we can discuss where are problems you can ask. So that is the idea. So, or I will just show how it will, or how you could have made it. So the first dApp would be super simple, just tic-tac-toe on the blockchain. Why? I mean, first it's just to do something and to get started. But actually, I have a use case for it. There are a lot of ideas about decentralized governance out there. So you would have some DAO, decentralized autonomous organization, that would make decisions on its own or in a decentralized way. And the question is, can you manipulate it? And so if it is good, then it should at least win or get at least a draw in a game of tic-tac-toe, right? So you could create a contract, and then you could challenge this decentralized mechanism, so maybe a voting mechanism, or you can use a prediction market as a decentralized governance tool. Anyway, so it should at least be not possible to manipulate the decentralized decision-making process so that it would lose the game of tic-tac-toe. So that's the first idea. The second idea is one of the things that are most easy to build are just tokens or just some coins. And I have this, or I just had this idea. Whatever the name is, I don't know who of you know this HODL meme from Bitcoin, but anyway, so we create a coin, and the property should be it should be decentralized. So it's boring to create a coin where you just say, okay, I initially create. We have a decentralized mechanism to create new coins, and on the other hand, it should be maybe, or in this case, it should still be mainly free. So what's the idea? So you get some coin if you lock up Ether. If you lock up 10 Ethers for 10 days, you get 100 coins. If you lock up 1 Ether for 5 days, you get 5 coins. So those coins are basically, you can get them for free, but they still have some scarcity. So if you want to make some project and you want that users can join more or less for free, but you don't want to have a spam problem, then you could, for example, use this coin. So just a second small idea for a DApp or coin. If you build it, you should definitely look into this standardized. So in the token standard, there is a standard for tokens, and if you implement it, then other tools will or you can use this coin for other contracts. For example, our prediction market, you can use everything that implements the token standard, the default wallet, the Ethereum wallet. Can also handle coins, and then you just have a default interface that users could use, like send a coin and see how much balance you have, and this simple stuff. Okay, the third idea is, I don't know who of you has the same problem. I always have the problem where if I need to prepare something or need to write something, I do it really in the last minute, so I finished the slides like 2 hours ago. Same goes for thesis or blog posts or whatever. So the idea would be a small step that you commit yourself to do something at a specific deadline. So let's say you want to write a blog post on whatever. And you say, okay, I want to do it in the next 3 days. What you do is, what the app would do, you can lock some Ether up, let's say 20 Ether or 100 Ether, whatever, and you commit yourself to write it. And actually, if you do not do it, then the coins are either destroyed or are sent to something you really don't like, or I don't know, you fund some campaign or whatever. So that's some kinds of those things. Right. So what is needed in addition? You need to specify someone who evaluates whether or not you have written it. So one idea would be, okay, you submit a thing to Pastebin or to IPFS. Then to get your coins back, you submit the link to this where you uploaded your content to the smart contract. And if someone agrees, yeah, that is indeed 3 pages of a blog post, then you get your coins back. Otherwise, they are destroyed or whatever. So those are just 3 ideas for small dApps. And now, what are the first steps to build them? Maybe before you want to build your own dApp, you want to have a look at what dApps are there already out, what dApps are already in existence to get an idea. Maybe to look. It's also a good source to. A lot of them are open source, so you can just look at the source code, and that's often the easiest way to get started to start with something similar and exchange something. Just to get a brief impression, who so far has coded something on Ethereum or written some solidity contracts or? Okay, not too much. But and who is who is an engineer, coder in general, or you? Okay, perfect. Okay. So maybe one more question to get a sense at what level I should talk about it. For example, who knows the difference between a transaction and a call in Ethereum? Okay. Then then a very brief overview of how basic architecture looks like. So in the left, bottom left, that's Ethereum. Part of Ethereum is the EVM, Ethereum Virtual Machine. It's like, for example, the JVM. It's a virtual machine, and it's important for Ethereum to make everything deterministic. So, I mean, in the end, your contract should be run. It will run on different nodes, on different, completely decentralized. But everyone has to come to the same result. So you need a completely deterministic virtual machine, and that's the EVM. Maybe the main thing that is added to guarantee this deterministic property is this idea of gas. So every computational step, call it opcode, costs a specific amount of gas, and then you basically avoid the problem to run into an endless loop, or I mean, you cannot say halving problem. You cannot say before the start program whether it will finally terminate. With this idea of gas, so that you specify a limited amount of gas and start to run it, then you know it will terminate, because either it directly terminates or it finally runs out of gas, then it terminates. Right. So that is the EVM. We have those smart contracts. Those are basically an Ethereum address with a bunch of bytecode. And we have, for those contracts, we have in addition a contract state. So just a bunch of key value stores, just a bunch of data and state of the contract. That is, I think both the EVM and I guess all three are the big difference towards Bitcoin. Otherwise, you have lots of things that are similar. You have block headers, you have a chain of block headers, you have currently proof of work. We'll switch to proof of stake later, but currently, other than those three elements, the Ethereum blockchain looks more or less like Bitcoin. Okay, then we have those two high-level languages. There are more out there, but those are the most important. Solidity and Serpent. So to write a smart contract, you don't have to write bytecode, thankfully. Instead, you write high-level language Solidity. I will talk mainly about Solidity because it's the language that has most support. You write your Solidity code. You will compile it to bytecode. You send a transaction to the network, creating a new contract with bytecode, and then people can interact with this contract. How do they interact? In principle, they can do it directly over the command line or directly using several tools I will show. But for the end user, it's nice if they have the DApps, so UI, decentralized application, that is regular HTML, JavaScript, and so on. And it will talk via the RPC interface to the network, to the Ethereum network. And also yeah, you can also create a transaction in the DApp and send it via this RPC interface to one node, and then it will be propagated to the Ethereum network and included into the next block, and will change the contract state. I will show this in a few examples very soon. So the next step, or the next things I want to show you is, let's get started. Let's write some Solidity code. So the first simplest tool, but I think that's the right one to get started, is the Solidity Online compiler. So that's how it looks like. You have here some example contracts. Here's a crowdfunding contract. Solidity is more or less pretty straightforward. So it's statically typed. Whoops. It's statically typed. We have, bool. I don't have to talk about that. That is an address. That can be a different contract or a regular address where you can just hold money on it. Okay. I won't go into details on Solidity. There are tutorials out there. There is a feature overview, but I think it is more or less pretty straightforward. So maybe some magic things is this message sender, message value, but it's easy to figure out what it means. So let's have a look. What else do we find here? So the nice thing about this tool is that you have you can create a virtual EVM. So or you can you have the EVM in your browser with this JavaScript VM, and that means you can virtually deploy it in the browser. So I click here on create, and now I created this, or I basically deployed this contract in this virtual Ethereum chain, and actually now I can use the function call. So or I see what's the returning value of the function call would be. Right. So here's the bytecode. That's the interface. So basically the function name plus the types of the input. Here, that is what you would need to paste on the command line. Okay, maybe that's. I guess it's small to see it there, but okay, that's what you need to paste on the command line to deploy it on the actual Ethereum blockchain, right? To deploy a contract, you can also use this Ethereum wallet thing. What's important here is you can switch between the main network and the test network. Use obviously the test network first. Get some free ether at, for example, here test.ethercamp. You get free ether. Then you have your wallet here. You can send free test ether to your account, and then you can here contract custom contract, deploy new contract. You can basically just paste your Solidity in there and deploy it. Okay, so let's move on. So that's the Solidity Online compiler. To look at the architecture, what does it do? Okay, it helps you. Oh, wait, let me go. Yeah. When? Right. So what you are creating in the smart contract, or what you create with Solidity is this bytecode that is on the contract address. And if someone interacts with this address or with this contract, then it will trigger the code you have written, and those are the rules how the state will change. So yeah, right. As soon as someone creates this transaction and addresses this specific contract, then it will trigger whatever, so they can add data to their transaction, and then they can call a function there, or so they can interact with, they can basically run the contract. Right. So the question was, contracts are public. Can they be called by anyone? In principle, yes. But you can build stuff into the contract that the first thing would be if sender is equal to whatever, or if it's not equal to whatever, then just terminate. So you can build into the contract any logic or any restriction you want.
So in theory, if you were to call a random program like
right. So the question was, will it consume gas? And I think it does, but it does not consume the gas of the contract, but of the sender. So if you create a transaction, then you have to pay for this. You have, as the creator of the transaction, you have to pay for the gas. So the contract, in principle, never pays for the gas. It's always the person who is creating the transaction, and this person will pay for the gas. Yeah.
If you show us Solidity was like gas values for each of the function calls, how do they determine?
Right. Oh, yeah, right. So it is possible to calculate how much gas will be consumed by a function call, and so if we so that is the block explorer, and we can see here at some we can see here some contracts that are deployed on the blockchain, and okay, I want to show you the bytecode. Give me one moment. So yeah, the question is still how is the gas cost determined? And okay, contract creation. Okay, I want to show it. No. Okay, let's find a contract that was actually used. Those contracts are just only created but never used. I want to find a contract that was used. Transaction count. Here we go. Maybe I go to contract that I maybe know. Okay, I don't. Let's have a look here. Right. So this is the current state of this contract. So you can see what variables there are, or what storage there is. And then here, for example, is a transaction. And what you can see now is, for example, the VM trace. So those are exactly on virtual machine level the opcodes that are, or the steps that are triggered by the transaction. And each of those steps, there's a list of those, I don't know, 50 opcodes. Do you know how many there are? How many opcodes? Anyway, 50 opcodes, and each of those opcodes has a specific gas cost. So simple addition of two numbers, of two integers, is maybe 3 gas or whatever. Writing storage is way more expensive. So every of those are the opcodes. Each of those has a specific amount of cost, and the total gas costs are just the sum of those opcodes. The question now is, can you know before you send the before you created or when you created the transaction, do you know what the costs are? And the answer is it depends. It depends. So there are some contracts that where the contract execution path is always the same, no matter what the state is. And then the costs are, you can calculate the cost exactly before. But if the execution path, let's say if variable A is bigger than than 1, then do something very expensive. If not, then just quit. Then at the moment you create the transaction, you will not necessarily know that you send your transaction to the network, but during this process, the state might change because some other transaction comes in early. So it's not always completely, you cannot 100% calculate it before when you create the transaction, at least not in every case. Okay, yeah?
How are these gas costs determined? Do they change or?
Well, right. So they, in principle, they do not change, or at least it would be indeed a hard fork. So it might happen that at some point the whole Ethereum community agrees and there will be a hard fork. Then it might change. And there was just in the last hard fork in Homestead, there was a new opcode introduced. But in principle, those gas costs are part of the protocol, and they will not change. Yeah.
Can I get those solidity code from bytecode?
Yeah, the question was, can you get solidity code from the bytecode? And the answer is a little bit. First of all, no. So it's not directly possible. Because there are lots of possible solidity codes that would result in the same bytecode, right? So, for example, the names of the variables can be whatever. So there are interesting tools out there that, for example, look at the solidity code and try to figure out, or they look at the bytecode and they find out what is the signature of the function, and then they scrape GitHub and paste in and just public resources, and they try to match them. Here at this block explorer, you can voluntarily, if you have deployed your contract, you can add the solidity code, and then the block explorer can verify, okay, then block explorer can compile the solidity code down to bytecode and see, okay, that is indeed the same thing. So you can verify that this is that. I think for this contract there is a solidity code out there, but you cannot get the solidity code for the contract in principle. Yeah. Okay, one more. Yeah.
The difference between the gas and the state is not much, right? It's not that material.
Once again.
So you're saying that it takes a different amount of gas to execute.
Oh yeah.
There's not a large difference, correct?
It really depends. So in principle, you can do something. I would say in a normal contract, the difference is not big. But in principle, you can create a contract where the difference is as big as it gets. You can create something where you have in the first line something directly quit if this, or go in an infinitive loop if not. And then you have basically very little gas consumption and infinitive gas or another execution path where you would just run into out of gas error.
How much gas is one rate?
Once again?
How much of one gas do you pay?
Right. So the concept of So there's not the direct connection between gas and Ether. Gas is paid with Ether. So what you do is, if you create a transaction, you specify a gas price. So you specify how much Ether you are willing to pay per gas. And then the miner can decide, do I want to process this transaction or not? So what you need to specify a gas price, and you need to specify a gas limit. So I want to do not spend more than, let's say, 100,000 gas. So with, let's say, the gas price is 20, the gas limit is 100,000. Then 100,000 times 20 is about 2 million. Is it? No. Okay, right. So you have to put 2 million Y to the transaction, and you have to pay that upfront, and you get back, or if the transaction is executed, and in the end it only costs 50,000, then you get half of the money back. But the miner has to guarantee that. The advantage of this is that the miner just needs to look at the gas price, and then he knows, okay, he's fine. So currently, you can look up, right. So currently, the gas price. So that is a nice overview of the Ethereum network. Here you see, for example, the gas spending per block of the last 20 blocks or something. You see, okay, that's the gas limit. So all transactions together in a block are not allowed to exceed this 4.7 gas. So here was a block, okay, that needed half of the limit. So there's room for more transactions. So there's a number of transactions in a block, and somewhere I guess there is the gas price here, right? So 20 Y. I'm not sure how much Y that is, but yeah, you can figure that out. Okay, I try to continue a little bit with my presentation, and then I'm totally open for more questions. Right. So. Okay, so the next tool I shortly want to introduce to you is maybe the next step, or maybe that's the right tool if you want to do a little bit more than just writing one contract with this online Solidity thing. So it's a command line development management tool called Truffle, and I show you shortly how it works. So here. What do I need? Oh yeah. Oh, higher or what? Right. So what Truffle does is, so first of all, okay, I think I need to quit this one. Right. So. Oops. So test RPC, yeah, you should look for test RPC, JavaScript, Ethereum, and you find the GitHub repo. So that is also now running a virtual Ethereum node on my in the command line. So when you start it just creates a bunch of accounts, and those have a specific amount of Ether. And Truffle works nicely with this test RPC thing. So what Truffle does is so I make a new folder. And I just use Truffle init. Whoops. Okay. What it just did is it created a an example DApp. So the next step, I can show it to you. Right, we have the app with a simple simple HTML, JavaScript, style sheets. We have here some example contracts. We have different environments and the test. Okay. So next step would be truffle compile, I guess. So yeah, compile step. And right, and we have to do a truffle serve. And now what happens is that we have a wait. Okay, so we have a small example DApp of just a coin, and I forgot one step. I forgot to deploy the contract on this virtual node here. So I do a deploy. Right. So you see here, it just created a new contract at this address, gas usage. I got a transaction receipt. Another contract was created. Again, gas usage, transaction receipt. And now if I refresh the site, whoops. Oh, right. So I have to do truffle serve again. Right, and now actually, here we go. We see we have 10,000 meter, some random coin. And yeah, you can see in this, you could find it in the example contract that we initially create for ourselves 10,000 coins. And now we can send, for example, coins to another address. Just need to get some Ethereum address. Whoops. That's maybe in the. Okay, here we go. So yeah, so it created a transaction. It sent this transaction to this virtual Ethereum node, and then the state of in the virtual Ethereum node was changed, and then the DApp does a call to the virtual Ethereum node and gets this result, and was changed. Okay, so that is truffle.
So truffle is application server. This application server, you can create JavaScript.
Yeah, so it helps you compiling stuff. So you just do this truffle compile, then it will compile everything that is in the contract folder. You can do truffle deploy, then it will create all the deploy transactions. You can configure it to have a little bit more sophisticated deployment script to do. I mean, if you have dependencies, that you first need to deploy that and then get the address from this to use this as the input for the next deploy thing, and so that all of this truffle can manage for you. It can do things that it would automatically run tests as soon as you alter the code. Just look at the
comment. I just want to make sure I'm following along. When you ran that just now, just running locally or
right.
Running on the test network?
So that was a really local network. So just here, now I just shut it down, and here if I hit this test RPC, then I spin up this local network. I could to go on the local chain, I could run a guest node and add testnet to it, and now I could use this DApp on the real testnet. But since I have not deployed it on the real testnet, here we go. It does not find the contract. So I could, yeah, if I go here for the local thing, it should be possible to do the draft or deploy, I guess. Right. So what now would be necessary that I unlock my account so that it could indeed spend the test ether, but in principle it is. Oh yeah, right. So I need to add a -RPC here. I'm not sure if I can make it work now, but right. Now I have a thing of could not unlock signer account. And I could do this again, but I think that, so what I would need to do is get attach. So now I have a command line tool to work, to speak to the local node, and I can do things, I can do things like account, or what is it? Right. Yeah, here we go. Here are my accounts, and now I can do something like personal unlock account. Is count 1 password. So my password, my super secure password, I think it is password, and the time I want to unlock it in seconds. True. Okay. Cool. Let's do it. Deploy. Okay. So maybe it's using count 0. Okay, and then there was this last thing that I think the connection, or my internet connection doesn't allow me to connect to the Ethereum network, I guess. Yeah, I am. I have a wire here, so I am connected to the internet, but is it? Is it connecting? Yeah, it is. Right, it is. So it should work. So look. Oh yeah, here we go. So it indeed deployed this contract on the testnet at this address, and we can look it up in a block explorer. So we go to test ether camp, and we look up this address. Yoo-hoo! So here we go. So that's the contract we just created. Is it? No, it's not. Okay. Anyway, let's continue. But this is how it works. Deploy to address. Okay, maybe one more try to. Okay, I'm not sure why it is not here. This is in principle. Once again. Yeah, I mean, but in principle, this should also be available. Maybe the transaction is still pending, or currently don't know why it. Also, this I think this block explorer is the best, but still it's not always reliable. So I blame it on the block explorer.
Okay, let's continue. So that was Truffle. So just the parts that are marked red are things that where Truffle helps you with. So it helps you to use, instead of the real Ethereum network, a virtual network, so the test RPC thing I showed you, or testnet. And yeah, there are things like deploy your contract. Once again, I guess I haven't used it with Serpent, but it should. I mean, if it's pretty sure it's possible, yeah. Okay. What's next? Just to mention it, there is this full IDE called Mix. So yeah, it is. It's a full IDE, and so there you can see the current state. You can see a few accounts. You could deploy here something, and then you also see the state of the contract. I haven't used it too much, so what can I say? So it's under development. In my opinion, it has some usability issues, but in principle, it could become a great tool. Let's put it this way. Okay. Anyone who used Mix so far? Okay. What's your impression of it? Or okay.
Yeah, I can never get the browser part.
Once again?
So it has an interface where you code and it shows you.
Oh, yeah.
I always have like a network error.
You mean this one, right? So yeah, so indeed it shows you here the Solidity contract, and then right. This is the index HTML. So yeah, that is a small browser, and in principle should be possible to. I mean, you have it all in one tool.
So within the IDE, you're mixing your Solidity code or whatever, as well as your surrounding JavaScript or whatever else you're going to.
Right. I mean that is a good practice, I would say. So I will like to show you. So it's a good thing to have the Solidity contract and the DApps, the interface, the UI in the same structure, and you will have tools that automatically create the ABI, so the interface towards your contract, and to use it in the JavaScript that calls those functions in the contract. Okay, let's go on. Okay, so then there's this web-based IDE called Ethereum Studio. It's from the same team, Easter Camp, where I just showed you the block explorer. It's currently in closed beta, so actually I can show you that it is live. It is. Here we go. So here you can see that is live. I got access one day ago, so I haven't had too much time to look into it. I looked at the earlier version a few months ago. I think it will really be a super interesting tool. You can collaborate with different people on the same contract. you can directly here do things like, again, set up a virtual node, deploy the contract, look at the state of the contract. So do some transactions, usual stuff you can do with the IDE. And actually you can step through, so you have a real debugger, you can step through contracts, see the execution path, and all those nice things if you want to go deeper. And again, here's also the structure is that you have the contract together with some front end for it. Okay, let's continue.
So all of the examples you're showing here have kind of JavaScript and code base. Is that the typical way people use it, or are they mixing it with Python and C++ and Go and whatever else?
Right. So I think all at this point in time, all DApps have a web front end. There are no, maybe as far as I know, there are no native DApps that would have yeah. So the common thing is to have a website that interacts over RPC calls from JavaScript to somehow a node, and that node can be can run locally on your computer or can be a remote node. Okay. Right. So the thing I had to add just today, because it was only announced today, is before I was here, I was at the Microsoft Build conference, and there Microsoft announced that they added Solidity support to Visual Studio. So I cannot tell you more about it.
You want to demo it?
Yeah. Okay, so I had something more prepared, but maybe we leave it at this point and just end it and have a. If you are interested in a little bit more Q&A, but some tired faces also, so I just want to don't bore you, so I'm not sure where we go. Yeah.
How is the price for Oculus set? Is it variable over time? Is there many?
It's fixed. So it's fixed. So there is a list of 40 whatever. Don't know the exact number, but it is fixed. And if it would change, that would mean a protocol change or a hard fork.
Maybe you meant the price of gas.
Well, no, I'm more curious, like, if for instance, storage gets cheaper over time on hardware,
Oh, yeah.
do you account for that, or I think it's output one center network to others, does it get cheaper over time?
So there's no plan for this currently, no.
Oh, like the appendix G, like the yellow. Yeah, where it actually has like that. I think it's the number,
Yes.
yeah, the ratio to zero, like something.
Right. So the question was again, what's the ratio between gas and ether? So how? And you can set it yourself. So you can, if you create a transaction, you can set your own gas price. So what are you willing to pay per gas in ether? And then a miner can decide to accept it or not. So it's like a Bitcoin transaction where you can set the transaction fee.
Well, what is sort of, it's going to be like an appendix G where it says, okay, this amount is
Right. So the total amount of gas that will be used, that's totally deterministic and depends only on what opcodes are used during the process. But what you are, so let's say the price is 10,000 gas. But what you pay per gas, that is a different question. And you can pay, and that's the gas price. So if you think about it, then okay, so you want to drive from here to New York, so it's clear that that will be so much gallons of gas. But what you want, but the price you pay per gallon, that's a different story. And that's something you can you can set it, and then you can basically make an offer, and then a miner can say, okay, I take this offer, and I sell you the gas for this price. I mean, it's not literal. I mean, yeah. Okay.
If my production runs out of gas, does the miner say to say that I can add more gas, or does my production go down?
No. So, the question was, what is the transaction runs out of gas, and to not end up in a situation where you have some invalid state. So, for example, you send already the money to some, so you increase already the amount of the other account, but you have not reduced yet. So what Ethereum does, if the transaction runs out of gas, then just all changes will be reverted. It will just completely be reverted, but you nevertheless have to pay the gas. So you lose all the gas, and the transaction is reverted. Yeah, good point. So you should know there's this difference between a call and a transaction. So at any point you can just a call is something like a virtual transaction. So at any point you can evaluate the function and get the result of it. So in your DApps you can show the result or the current state, obviously without paying gas. So you always, the only thing where you need to pay gas is if you want to change the state. So if you want to do a write, and that is a transaction. The terminology is kind of confusing because the transaction can then trigger other calls that are right. So I think we are still looking for the right wording between reads and writes and transaction and call. Yeah. Yeah, that's correct. So a call is, no one knows about it. You just query your own. Right. So the transaction. Right. So another difference between a transaction and a call is the call you just ask your local node and it will answer it. A transaction is something, a piece of data that you need to sign with your signature. This piece of data gets distributed in the Ethereum network, in the mempool, memory pool, like a Bitcoin transaction, and then a miner, some miner who includes the next block as hopefully your transaction in the mempool, and will run it. And the others will also run it to validate whether or not this new block was valid, because they end up to the same state. Okay, so I skipped this. I skipped this slide, or the idea behind it. So there are different ways to connect your DApps to Ethereum. I think I leave this for the next presentation. So the last thing I want to announce to all of you is, there's whoever is interested in a quick trip to New York. So there's a blockchain workshop conference next week for 5th April. I said it last 2 hours before the presentation I made. And if you want to get in and get up to a 75% discount code, ask me. Okay. Thanks. I don't know whether or not they accept Ether. Okay, so that was it now from my side. Thank you very much for your attention. So I'm totally happy to answer more questions, but I had the feeling that not everyone is interested in more questions, so I just want to give you a chance to speak directly to each other, and
Did you list all the tools that you know about, or is it just, there are more, right?
There are more, yeah, there are more.
Okay, let's jump. Well, you can finish these questions up a little bit later. If you want to tell or propose help host or present talks at the future events, please come talk to me. Anyway, let's thank Martin. Thank you. Yes.
Say you worked at Consensus.
Yeah, come in.
I was looking at no.
Yeah.
So, what is it?
I believe it's so if you hold down, you hit hold down, command tab rather.
Here it is, right? Right. I know.
Yeah, right here. Yeah.
I think
Yeah, either one should do it. Do you know how to do it? And now I'm recording, right?